Hello, I'm Paul Beckwith. I'm with the University of Ottawa in the Geography Department Laboratory for Paleoclimatology. In this video and the next number of videos that I'll be producing and uploading, I'll be discussing some of the highlights and lowlights of a paper. I consider it a landmark paper that has just come out this week. It's a 66-page paper. It's by, there's 16 co-authors on the paper, and the lead author is James Hansen. And the paper discusses ice melt, sea level rise, and superstorms. It gives evidence from paleoclimate data, climate modeling, and modern observations. And the main conclusion is that the 2 degrees Celsius global warming threshold is highly dangerous. Now, this 2-degree limit, established in the Copenhagen conference in 2009, is kind of a hand-waving argument that has been adopted by governments around the world in policy negotiation. And there's much evidence that this is a highly dangerous limit, because with this limit we will have enormous sea level rises, which will cause massive migrations and incalculable economic costs to society, which is clearly not acceptable. So this video is kind of an overall summary of some of the results and things that struck me, which I didn't know before. And then I'll have separate videos on each of the separate components. So the previous interglacial period, we're in the Holocene now. The previous interglacial or warm period on the planet was about 130,000 years ago, and it's known as the Eemian, or marine isotope stage 5e is the latter part of the Eemian. And in the latter part of the Eemian, the sea level was 5 to 9 meters higher than it is today, in that range. And there were also enormous storms, which we're not familiar with in the Holocene, much larger than anything we've experienced. The temperature at this time was up to 1 degree higher relative to today. Now, I say up to because there is evidence from various sources that the temperature was only a few tenths of a degree warmer than today, 0.2, 0.3 degrees Celsius warmer. So we're almost there. And of course, we're about 1 degree Celsius warmer than the pre-industrial period today. So a key thing to remember is that human forcings, the change in the chemistry of the atmosphere that humans have brought on by fossil fuel combustion and land use change, are much stronger and faster than anything we have seen in the paleo records. So the rates of change are enormous, at least an order of magnitude or more larger than what we've seen in any of the geological records in the Earth's history. The key finding that's discussed in this paper is that nonlinear ice sheet disintegration from ocean warming is occurring. There's nothing linear about sea level rise right now. There's nothing linear about melt rates of ice caps on Greenland and Antarctica. In fact, I've done previous videos asking, can sea level rise 7 meters by 2070? If you just look at the doubling period, which has happened in the last 20 years or so, it's about 7 years or so for melt rate from Greenland and Antarctica. And if you carry that forward, you come up with a number something like 7 meters by 2070. Now, there's lots of other things that are happening, so I may it's not a clear, simple picture. A lot of other things come into play. But the key finding is that there's ocean, the ocean's warming. We know that rapidly. But one of the important things is that the subsurface warming at depths of 1 kilometer to 2 kilometer, bordering Antarctica and Greenland, is fastest there. And this is the same depths at which the ice sheets, many ice sheets on the coast or ice shelves are grounded on bedrock that is 1 kilometer or 2 kilometers under the ocean. And those, the warm temperatures down there are melting the grounding ice, which is almost like, so what it leads to ice shelf, which are floating, massive floating thick, 500 kilometer thick sheets of ice that are extending out from the continent of Antarctica and Greenland into the ocean, and the ice is grounded well below sea level, and the warming water is melting that, so the shelves are collapsing, and that's like removing a cork, because once the ice shelf is gone, then the ice sheet or the ice cap on the continent can then move much more quickly. So this is a huge problem. There's also there's very large amplifying feedbacks in the Southern Ocean in particular. The descending water, which is part of the global ocean circulation pattern, is reducing. So the vertical ventilation is reducing. So the Antarctica bottom water production is reducing. So this is leading to large warming of the subsurface ocean, which is undercutting the ice caps. Also, the ice caps are on retrograde surfaces in Antarctica. So once there's enough melting, then the whole ice sheet, the whole ice shelf in that region can collapse. The other key, another key finding is that the increased ice melting from Greenland and Antarctica. Oh, in Greenland, a lot of the land it's prograde, so it's sloping down. So that's not as bad a situation as retrograde. But what's happening with all this ice melt, this anticipated and is actually starting to occur and be measured, is that it decreases the surface temperature and it freshens the surface temperature of the ocean. So south of Greenland, we're seeing this happen. Also around Antarctica, we're in early stages of this happening. So what happens as the ice cap continues to melt and inject more and more cold water, it causes regions of very cold water, and of course the overall warming causes regions in the tropics to be sea surface temperatures to be extremely warm. So what this does is it creates a large temperature difference between those regions, and that creates a large pressure difference, term known as baroclinicity. And what happens then is that it generates extremely large pressure differences and extremely high winds. So the ocean circulation patterns change, the wind patterns change, and we get persistent, very, very high persistent winds, and these generate large waves. And this study, where the position in the North Atlantic of the cold and warm ocean areas generates these waves with extremely large fetch. They blow extremely high winds over very large distances, and there is geological evidence to show that these waves build up, and they run from the northeast Atlantic to the southwest, and by the time they get down to Bahamas, there's evidence that in the late Eocene these waves were 30 meters high, so long period, extremely high waves. Further north in Bermuda, there's evidence that they were 20 meters high. So basically, the largest waves on the ocean right now are occasionally, these known as these rogue waves. They don't happen very often. It's from constructive interference of other waves, but they reach heights of 30 meters plus, about 100 feet, and they take down ships. So we're talking about late Eemian storms that are large enough to generate an ocean full of waves that reach up to 30 meters high down near Bermuda. So clearly there would be no ship traffic at this point of time. You know, an ocean of rogue waves has tremendous force. So this is a very, you know, key finding. Another key finding is that during the late Eemian, there's some evidence showing that the sea level actually rose as high as much as 2 to 3 meters in a few decades. So clearly this you know, enormous catastrophic rise would be caused by extremely large ice sheets or shelves breaking off of most likely Antarctica, but perhaps Greenland as well. So the other key thing is that in the past, it was deep ocean ventilation, you know, on a millennial time scale, or at least 500 to 2,000 years, that was that changed the CO2 concentration. So it was like the CO2 is the control knob for the climate. So the key point is that these time frames are not applicable to human time frames of chemistry, of changing the chemistry of the atmosphere. And that so these natural time frames for ice recession and progression and sea level rise and CO2 gas changes are not applicable to rates of change today. So I'll stop here. The key point to reemphasize is that 2 degrees Celsius of global warming is highly dangerous and unacceptable to humanity because of the enormous sea level rise that will occur with the 2 degrees. Thank you.